Hi folks, it's Richard Joe, conversion rate optimization expert. So today I'm back and I want to discuss and clarify a point that I made a few months back about the minimal detectable effect. And just to recap, the minimal detectable effect is essentially the minimum difference that can be reliably detected in your test results given the power of the test. And in other words, that's basically the same as saying that, let's break it down. So minimum is basically what's the smallest or the minimum, and effect is basically your conversion difference of your variation over the control, and detectable is basically what you want to see running from the experiment or what the result is. And just to recap on the minimal detectable effect is that it's actually related to also the power of the test. And the power of the test is basically set at 80%, or it's recommended to be set at 80%. And when you've got a test that's set at 80% power, you're effectively allowing for 20% of a 20% chance of getting a false negative. And like I said in a previous video, a false negative is basically when you say the test is a loser, when in fact in reality it's a winner. It's essentially the same as telling a pregnant lady that she's not pregnant. So going back to minimal detectable effect, and the what's recommended in the resources is that, or recommended best practices says that a MDE set at 5% and a power of 80% is basically your sweet spot for most websites. And related to that is how long you should be running your test for. So let's flip around and look into the Spiro pretest calculator. So just Google that, Spiro pretest calculator, and that will help us to determine how long we should run the tests at a MDE of, let's say, 5%. Okay, so here we are on the Spiro calculator. Just quickly showing you, let's just say you've got 140 website visitors weekly, you got 2,230 conversions, and you got 2 variations. Now, at an MDE of 5%, it's based, and that's at a power of 90%, confidence interval 90%, it's telling us to run the test for 3 weeks at